Hello smart civil engineers. I am Engineer Masroor and you are watching Engineering Network YouTube channel. I am back with another important topic. So in today's video our topic is how to calculate the quantity of materials for column in a house. Now I will find out the number of cement bags, number of sand trucks, number of aggregate trucks, and also the total amount of steel used in the construction of column. Okay, so this is basically the third part of complete house estimation course. So kindly watch this video till the end for better understanding. Now actually I have number of columns, and in today's video I am going to show you how to calculate the quantity of materials for multiple columns in a house. Now before I start this very important video, I have a request from you guys. So if you find this video informative, then please like this video, share it with your friends, and if you are new to my channel, then please click on the subscribe button. And also make sure to press the bell icon for more civil engineering videos. Okay, so in today's video, our topic is how to calculate the quantity of materials for multiple columns in a house. Now in the first two parts of estimation of house course, I have briefly explained about the center line method, and also I show you how to calculate the quantity of earthwork for house, quantity of PCC, quantity of brickwork in foundation, quantity of sand filling in foundation, and also the quantity of DPC as well. Okay, so if you are new to my channel and haven't watched the first two parts of the estimation of house course, then kindly watch it on my YouTube channel. You will find the course in the I button and in the description of this video as well. Right? Now let's talk about our today's topic, which is how to calculate the quantity of materials for multiple columns in a house. Now what is meant by multiple columns? Well, by multiple columns I want to say that in a particular house I have more than one columns. Okay? And also I will show you the plan of the house and also the position of the columns as well. So as you can see, this is the plan of house. Okay, and if you look closely here, these yellow squares at the corners of this house are actually columns. Okay, now in this house plan I have two types of columns. One is the square column and the second type of column is the rectangular columns. Okay, now the square columns are provided at the corner of this house. Okay, as you can see here, this is the square column. This is also a square column, and in these two corners I have also two square columns as well. Right? Now this is about the position of square columns. Now let's talk about the rectangular columns. So one rectangular column is provided here, one rectangular column is provided here, one rectangular column is here, and also one rectangular column is provided here, and one rectangular column is provided here. Okay, so this is about the position of columns in this house. Now let's talk about the size of these columns. Okay, so for the square column the size is 12 inch by 12 inch, right? Which means that the length and width of the square column is 12 inches. And now let's talk about the rectangular columns. Now for the rectangular columns, the size of these two rectangular columns is 15 inches by 12 inches, right? Which means that 15 inch is the length of the rectangular column and 12 inch is the width of the rectangular column, right? And the size of these three rectangular columns is 12 inches by 15 inches, right? Because these three rectangular columns are placed along the length of these three walls. Okay, so if you look at these three rectangular columns closely, you will see that these are placed in this direction or in the direction of house, right? And if you look at these two rectangular columns, you will see that these two rectangular columns are placed in this direction, right? So I hope you will understand about the size and placement of these rectangular columns. And still, if you have any confusion, then please let me know in the comment section. Now basically in this house plan, I have 4 square columns and 5 rectangular columns. Okay. So the total number of columns in this house plan is 9, right? So now we are done with the position of columns, size of columns and placement of columns in this house plan. Okay. Now let's start calculate the quantity of materials for these columns. So first let's start with the square column. So the volume of square column is equal to length into breadth into height. Here the length of the square column is 12 inches. Width of the square column is also 12 inches. And the height of all columns in this house is 10 feet. Okay. So the volume of square column is equal to 12 inches, which is equal to 1 feet, multiply by 1 feet, multiply by 10 feet. And the volume of square column will become 10 cubic feet. Now this is the volume of only one square column. Okay. And in this house, I have 4 number of square columns. So the total volume of 4 square columns is equal to 4 multiplied by the volume of one square column, which is 10 cubic feet. Okay. And the total volume of 4 square columns will become 40 cubic feet. Now this is the wet volume of these 4 square columns, right? Next is the quantity of rectangular columns. So the quantity of rectangular columns is equal to length into breadth into height. Here the length of rectangular columns is 12 inches. Width of rectangular column is 15 inches and height of rectangular column is 10 feet. Okay. So the volume of rectangular column is equal to 12 inches, which is equal to 1 feet, multiply by 15 inches, which is equal to 1.25 feet, multiply by 10 feet. And the volume of rectangular column is equal to 12.5 cubic feet. Now this is the volume of only one rectangular column, right? And as I told you at the start of this video, that I have 5 rectangular columns. So the total volume of 5 rectangular columns is equal to 5 multiplied by volume of one rectangular column, which is 12.5 cubic feet. And the total volume of 5 rectangular columns is 62.5 cubic feet. Okay. Now this is the wet volume of 5 rectangular columns. And also I have the wet volume of 4 square columns as well. So the total wet volume of 9 columns is equal to wet volume of 4 square columns, which is 40 cubic feet, plus wet volume of 5 rectangular columns, which is 62.5 cubic feet. And the total wet volume of 9 columns is equal to 102.5 cubic feet. Right? Now in order to calculate the quantity of cement, sand, aggregate and steel used in the construction of these 9 columns, I will need the dry volume of these 9 columns and also I will need the information about the grade of concrete as well. So first let's talk about which grade of concrete is used and what are the mix ratio of that concrete grade. Okay. So the grade of concrete which is used for this particular house is M20 grade concrete. And the mix ratio of M20 grade concrete is 1:1.5:3. And the sum of ratio is 5.5. Okay. And after that, I will calculate the total dry volume of these 9 columns. Okay. So here I have the wet volume of these 9 columns, which is 102.5 cubic feet. So the dry volume of concrete is equal to 1.54 times wet volume. And after putting the values, the total dry volume of 9 columns will become 157.85 cubic feet, right? So the total dry volume of 9 columns is 157.86 cubic feet. Now I am ready to calculate the quantity of cement, sand, aggregate and steel for these 9 columns. Okay. So let's start with the quantity of cement. Now the volume of cement is equal to 1, which is the ratio of cement in the mix ratio of M20 grade concrete, multiply by the dry volume of 9 columns, which is 157.86 cubic feet, divide by the sum of ratio, which is 5.5. And the volume of cement will become 28.7 cubic feet. Now for the number of cement bags, I will need the volume of one cement bag. Okay. And we know that the volume of one cement bag is equal to 1.25 cubic feet, right? So the total number of cement bags is equal to total volume of cement, which is 28.7 cubic feet, divided by the volume of one cement bag, which is 1.25 cubic feet. And the total number of cement bags will become 23 bags. Okay. So now I can say that for these 9 columns, 23 cement bags will be used. Next is the quantity of sand. So the volume of sand is equal to 1.5, which is the ratio of sand, multiplied by 157.86 cubic feet, divided by 5.5. And the volume of sand will become 43.05 cubic feet. Okay. Now for the number of sand trucks, I will need the volume of single truck, right? And let's say that the volume of single truck is 120 cubic feet, right? So the number of sand trucks is equal to 40.05 cubic feet, which is the volume of sand, divided by 120 cubic feet, which is the volume of single truck. And the number of sand trucks will become 0.358 trucks. Okay. Similarly, I will calculate the quantity of coarse aggregate as well. So the volume of aggregate is equal to 3, which is the ratio of aggregate, multiplied by 157.68 cubic feet, divided by 5.5. And the volume of aggregate will become 86.1 cubic feet. Okay. And the number of aggregate trucks is equal to 86.1 cubic feet, which is the volume of aggregate, divided by 120 cubic feet, which is the volume of single truck. And the total number of aggregate trucks will become 0.717 trucks. Okay. Next is the quantity of steel. Now for the quantity calculation of steel in column, I will use the thumb rule for column. Okay. So according to the thumb rule, it states that 2.5% steel is used in column, right? Now how we will calculate the quantity of 2.5% steel in a column? Well, for that I will need the total wet volume of 9 columns, right? And I have already calculated the total wet volume of 9 columns, which is 102.5 cubic feet, right? Now here the wet volume of these 9 columns is in cubic feet, okay? And I need to convert it to cubic meter because the density of steel is in cubic meter, which is 7850 kg per cubic meter, okay? So for that I have to convert the wet volume of 9 columns from cubic feet to cubic meter. Now we know that 1 cubic meter is equal to 35.31 cubic feet. Okay. So the wet volume in cubic meter is equal to 102.5, which is the wet volume of 9 columns in cubic feet, divided by 35.31. And the total wet volume of 9 columns in cubic meter will become 2.887 cubic meter. Okay. Now the thumb rule states that 2.5% steel is used in the column. So the volume of steel is equal to 2.5 divided by 100 multiplied by 2.887. And the volume or quantity of steel for these 9 columns will become 0.07217 cubic meter. Okay. Now I need to convert the volume of steel into kg and tons, right? So for that I have the density of steel, which is 7850 kg per cubic meter, right? So the quantity of steel in kg is equal to volume of steel, which is 0.07217 cubic meter, multiplied by 7850 kg per cubic meter. And the quantity or volume of steel in kg will become 570 kg. Okay. Also we know that 1 ton is equal to 1000 kg. So the final amount of steel is equal to 570 divided by 1000, and it will become 0.57 tons. So now I can say that in these 9 columns 0.577 ton steel is used. Okay. So this is how you can easily calculate the quantity of materials for multiple columns in a house. So in this video I have briefly explained how to calculate the quantity of materials in column, number of cement bags, number of sand trucks, number of aggregate trucks, and the amount of steel in tons. Okay. So I have done all this hard work only to make you guys understand in easy and simple way as possible. And in the return, I am only asking for, if you find this video informative, then please like this video, share it with your friends, and if you are new to my channel, then please click on the subscribe button. And also make sure to press the bell icon so that you will never miss a notification whenever I upload a new video. See you in the next video.